Hey, what's going on, guys? Hey, I'm back with another video. This is going to be 3 Pascal's triangle. All right, little binomial expansion right here. So, let's get in. All right, guys. Here's our standard right here, man. Know and apply that the binomial theorem gives you an expansion of x plus y to the nth of powers and x and y for the positive integers n. All right, man, we reviewed this part right here. All right, in class where we talked about a plus b to the 0 was 1. And then a plus b squared was 1 and 1. And then it says expand the following, so we're just going to expand. All right, expand. So this is a plus b. A plus b. All right, this one right here. Oh, that's to the first bar. Sorry. So it should just be this a plus b. All right, this one right here should be a plus b. A plus b. All right, cube a plus b times a plus b times a plus b. All right, and you can see. All right, so I went ahead and just expanded these. All right, so you can see them now. Right here, it says create a Pascal triangle to the 7th row. All right, well remember you always start with 1. All right, the 7th row. All right, so 1. This is the 0 row. All right, so 1, 1, 1, 2, 1. All I'm doing right here is adding. 1 plus 1 is 2. So 1's always on the outside. Then 1 plus 2 is 3. 2 plus 1 is 3. Then 1's on the outside again. 1 plus 3 is 4. 3 plus 3 is 6. And 3 plus 1 is 4. All right. And I'm just going to keep that going. 0, 1, 2, 3, 4. All right, this right here is 5, 10, 10, 5, 1. All right, then we have 1, 6, 15, 20. Hold on, buddy. 20, 15, yeah, 7. 6 and 1. And then we have 1, 7, 21, 35, 35, 21, 7, and 1. This is our 7th row right here. This is the 7th row. 0 row, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 7th row. And I know y'all hear my baby, man. He's sitting right here with me, enjoying some math. All right, he's enjoying some math. But anyway, right here, I'm gonna use Pascal to solve this triangle, or not. I'm gonna use the triangle to expand this binomial. All right, so let me show you how to do this. I'm gonna do the vertical method. All right, by vertical is just an organized way to look at this. All right, remember, first thing, I want you to identify your coefficients. So if we go back to our triangle, all right, matter of fact, let me go to the triangle we used in class today. All right, if I go to the triangle and label my rows, all right, I label my rows. All right, you see right here where it says x plus y to the 4th. Remember, start with the 0. This row is the 1st, x plus y to the 1st, x plus y squared, x plus y to the 3rd. This is x plus y to the 4th. So we're going to use these coefficients right here, all right, for our polynomial. All right, 1, 4, 6, 4, 1. We're going to use these. So let me show you how to do this vertical method. All right, for this problem. So the vertical method, guys, is like this. You're going to go 1, 4, 6, 4, and 1. Okay, 1, 4, 6, 4, 1. Next, what I want to do is identify my a and my b, or my x. All right, this is x, 2a. All right, and this is b, negative 3. Or excuse me, y, negative 3. All right? So what I do is I take these and I'm going to apply my exponent in descending order to each one of these. So right here, I'm going to go to A, and I'm going to raise that to the fourth. I always start. Excuse me. Now I know somebody's going, why are you starting with the fourth? Well, see how the degree here is the fourth? Alright, since the degree is the fourth, I start with the fourth. Alright? And then I'm going to go 2A again. And I'm going to go cube. And then I'm going to go 2A again. And I'm going to go squared. Look at I'm going down. And then I'm going to go 2A again. And I'm going to go to the first. And then I go 2A again. And I'm going to go to the 0. Alright, so 4, 3, 2, 1, 0. Next, I'm going to do my y term. Alright, -3. But with -3, I'm going to start with 0. And then I'm going to do -3 again. I'm going to do it to the first. And -3 again. And do it to the second. And -3 again. And do it to the third. And -3 again. And do it to the fourth. And the reason I'm doing this is because, see how this goes from 4 to 0? Well, this needs to go from 0 to 4. Alright, let me zoom in so I have some more space. That's kind of big. Let's zoom out. Let's go this way. Alright, now the purpose of this is so you can see everything evaluated a little organized fashion. Alright, so now, man, when I evaluate this, alright, I have 1. Now right here, I have 2A to the fourth. Well, remember, this is multiplication. So because this is multiplication, I can apply this 4. Alright, I can use the power rule and apply this 4 to everything. So I can do 2 to the fourth, alright, which is 16. And then I can do A to the fourth, alright, which is A to the fourth. Alright, and then right here, I'm going to do -3 to the 0. Well, remember, anything raised to the 0 power is 1. Alright, so I have 1 times 16, A to the fourth, times 1. Again, let me explain this one more time. 2 to the fourth is 16. 2 times 2 times 2 times 2. Alright, and A to the fourth is A to the fourth. -3 to the 0 is 1. Anything raised to the 0 power is 1. Next, I'm going to do this one. I have 4, right? Now, for this part right here, 2A cubed. Remember, this is multiplication, so I can raise everything to the third power. 2 to the third power is 8. A to the third power is A cubed. Now, right here, I have -3 to the first power. Well, that is -3. All right, -3 to the first is just -3. Next, so now, all right, we have 6, and we have 2A squared. Well, 2 squared is 4. A squared is A squared. And right here we have -3 squared. Well, -3 times -3 here, I'll do it right here for you. There you go, -3 times -3. Well, guys, that's +9. Alright, that's +9. Now, please, man, don't get discouraged. You're like, oh, it's a lot of work. No, I'm breaking it down for you. Alright, I'm going every single step, breaking it down for you so you can get the concept. Alright, this is faster than expanding that 4 times and foiling, okay? Right here, I have 4, and then you have 2A to the first, right? 2 to the first is 2. A to the first is just A. And right here, -3 cubed. Well, that's -3 times -3 times -3. Those two is +9. So now 9 times -3 equals -27. And then lastly right here, we have 1 times 2a to the 0. Well, remember, anything to the 0 power, just like up here, anything to the 0 power is 1. So this to the 0 power is 1. And negative 3 to the 4th. Remember, negative 3 cubed is negative 27. So times negative 3 is positive 81. Alright? Positive 81. So now, all we do is simplify each row. Alright, we simplify each row. And then we'll have our polynomial. Alright, right here we have 1 times 16a to the 4th times 1. Alright, so that is 1 times 16a to the 4th times 1 is 16a to the 4th. Okay. Then we have 4 times 8 is 32. And then 32 times, or 32a squared, a cubed. 32a cubed times negative 3 is a negative 96a cubed. And then right here we have 6 times 4, that's 24a squared. And 24a squared times 9 is going to be 216 a squared. And then right here we have 8 to 4 times 2a is 8a. And 8a times negative 27 is a negative 216a, sorry. And then we have 1 times 1 times 81 is 81. Alright, so guys, this is our polynomial. Alright, we will just write it in descending order. 16a to the 4th minus 96a cubed plus 216a squared. Again, that's plus because it's positives. Alright. Minus 216a plus 81. This is your polynomial. Alright. Using binomial expansion or Pascal triangles. This is it right here, okay? Alright. Let's try another example. Alright, one more example for you. And this time I'm going to use just a straight horizontal method. Alright. Use Pascal triangles to expand this. 3x plus 2y cubed. So the coefficients, x is 3x. Ooh, didn't mean to erase that. Alright, so here's what we got. Cube. Well, let's look back at the triangle. Alright, this time we want the cubic function. Not the cubic function, but the cubic exponent. Alright, so for that one, we're going to look at this entire row right here. This is cube. Alright, so we're going to have a cubic polynomial. 1, 3, 3, 1. So when we do that, we have 1, oops, that's the highlighter. We don't want that feature. There we go. We have 1 times 3x. And we see how this is 3. So we start with cube. And then we have 2y. Remember, we start that with 0. So 3 and 0. Then we have 3 again. Alright, again, that was the next coefficient. 1, 3, 3, 1. So 1, 3, 3, 1. 3. And I have 3x. And I'm going to go squared because 3x first cubed. Now 3x squared. And I'm going to go 2y to the first. See? Go up 1. Then I'm going to go 3 again. And 3x to the first. See, 3, 2, 1. And I'm going to go 2y squared. 0, 1, 2. And then finally 1, right? Times 3x to the 0. And 2y cubed. Now, let's go ahead and expand this thing. Well, it's already expanded. Let's go and simplify. So I have 1 right here. 3x cubed. 3 cubed is 27x. And 2y to the 0 power is 1. Anything to the 0, guys, is 1. Except 0. Right here, I have 3. 3x squared is going to be 9x squared. 3 squared is 9. X squared is x squared. And 2y to the first is 2y. Then we have 3 times 3x to the first is 3x. 2y squared. 2 squared is 4. Y squared is y squared. Then we have 1. 3x to the 0, guys, is 1. And 2y cubed is going to be 8y cubed. Alright. Now we simplify. Right here, 1 times 27x times 1 is going to be 27x. 27x. Oh, you know what I didn't do? See that cube right there? I forgot to cube that, guys. Sorry, I'm just not catching that. All right, right here, we have 3 times 9. That's 27. And 27 times 2 is going to be 54. X squared. Now don't forget this y right here. X squared y. Then we have 3 times 3 is 9. Alright, so 9x times 4y squared. Alright, 9 times 4 is 36. Oh, I didn't need to write the 9. It's 36. Alright, and then we have 36 times 4. I'm sorry. 3 times 3 is 9. 9 times 4 is 36. So we have x, y squared. There we go. And then lastly, we have 1 times 1, which is 1, times 8y cubed is 8y cubed. So, man, this is it. This is our polynomial, our cubic polynomial. So you pick whichever way you like, man. There's this vertical method or this horizontal method. All right, it's the same as that thing, though. All right, it's the same thing. You just got to decide which way you like. All right. Now, right here, what is just the 4th term? All right, so the 4th term, if you go back to say this is the 5th, and we look at our right here, the 5th, x plus y to the 5th, the 4th term, 1, 2, 3, 4. We apply that coefficient. All right. So we have 10, 3c. So if you remember, you start with 5. So 5, 4, 3, 2, 1. So 1, 2, 3, 4, 2. So 10c squared and 4d 0, 1, 2, 3, 4 cubed. All right, now remember these are how the exponents will go. Start with 5, go down to 1 for the first term, and start with 0 and go to 5 for the second term. All right, so actually 0, 1, 2, 3, 4. So I got the wrong ones, guys. 1, 2, 3, 4, 2, 1, 2, 3, 4. No, 3. This is good. This is good. Sorry about that. So now we will just evaluate it to get 10 times 9c squared times 4 cubed is 64 d cubed. And then we will just simplify that, all right, to get, let's see, 10 times 9 is 90. All right, times 64 is going to be let's see here, 5,760, and then c squared d cubed. All right. Right here, what's the 3rd term? All right. Well, The third term, I would just expand it out, figure out my third term. And then right here, you know, let's do it. So we have to the fourth. All right, so if I look back real quick, the fourth power is here. Then with the third term, so 1, 2, 3, 6. Yeah, 6 is the coefficient times 3q. Let's see, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. So 1, 2, 3, 2. And negative 2. 1, 2, 3. Alright. So we get 6 times 9q squared times 4. So 6 times 9 is going to be 54. And 54 times 4 would be 216 q squared. Now, what is just the coefficient of the second term of x plus 5 to the fifth? So they want just the coefficient, like that's the coefficient. So just the coefficient, x plus 5 to the fourth. Well, again, this is the fourth. So the second term, look back at your triangle right here. 4. The second coefficient. So we're going to do 4 times x. Alright, x to x squared. Oh, excuse me, x cubed. That's the second one, right? 4, 3, 2, 1, 0. 0, 1, 2, 3, 4. And then you're going to have 5 to the first. Anyway, for the coefficient right here, you get 4 x cubed times 5, which is 20 x cubed. With the coefficient is 20. Alright. Man, well, look, listen. That's it for this. We're going to spend some time in depth practicing in class. We'll work up to these type of problems. I just wanted to include it on the video so that way at a later date I wouldn't have to reference it. I could just point you in this direction if you need some extra. Alright, but we're going to practice in class. Alright, we're definitely going to practice in class, so please bring your motivation, man. Let's get this done. Catch you later.